Hey guys, I'm going to do a quick video here tonight on EMS Systems, just real basic system layout, so we all have an idea of how these things are supposed to work, or just basic knowledge. So Home Depot, Target, Kirkland's, Ulta, some of our customers that have EMS systems, this is their offices. Their office is connected to the internet like the rest of us are. Their store is also connected to the internet, so their headquarters talks to the store. In the back of their store, typically in a Target store, it's in the electrical room. In the Home Depots, it's in the electrical room. In an Ulta, it's back in the stock room where the electricals are. There's a box that has EMS stuff in it. In the Target store, guys, it's an IOP panel. Most of you guys know what this stuff looks like. Inside an IOP panel at a Target is an LGET panel. The LGET is the portal. This is where the network cable comes into the store, ties into this panel, and goes directly on at a Target into this port. Now Target is talking to their store via the internet. The LGET, or on most and pretty much any of our stores, is basically just a router, guys, like we have in our house at home. It's just a router. It's just the internet portal to get them into the store. This talks their language, is all that's going on there. So with that said, now you're into the store. That's the router. The units in the store are connected via cable. Usually one cable comes out of that router, goes up to the first unit. Inside of each unit at a Target, you've got a ALC, automated logic, RTM module for a rooftop module or refrigeration thermostat module. At a Home Depot, this is made by Nobar, but Lennox puts their name on it because they're proud of it. This is an ETM, electronic thermostat module. Guys, these are just thermostats, and there's no magic or rocket science here. It's just a thermostat that talks to the internet is the only difference. So you take a Vision Pro 8000, you got a router, it talks to it, it can tell it how to change its program in the middle of the day. You can read its temperatures, tell you if it's running or not. This thermostat runs on its own without the internet. The internet is just a communication so they can talk to each other. This unit can run without the internet, just like a thermostat can. If you lose communication to a Target store or a Home Depot store or an Ulta store or a Kirkland store, you have not lost the store. Target just cannot talk to their store. This unit and every unit on the roof will run on the last known program stored in its chip. So if its cooling set point is 74 and you cut the communication wires down here, this controller will continue to run this unit. So the myth, when the office calls and everyone's panicking because they just had a whole store in comm loss, and the assumption is the whole store is down, the lights are out, and everyone's going to die from heat stroke. Complete myth, everyone. These units have built-in programs just like a thermostat. The only thing that has happened is Target, Home Depot, or Ulta can't talk to the units. They don't know if they're running or not. They don't know what the program is. They don't know if the lights are on or not. But the units run on their own. They just lost communication. It'd be like Metrotech when the phones and the internet goes down. The office doesn't burn to the ground. The only thing that happens then, as we know as technicians, is our phones get quiet and we can get some work done for the afternoon. So... office people, if you're listening, sorry about that, but I had to throw that in there. Anyway, stock room, you've got your router, whoever the customer is. Cables come up to the units. Inside the units, you have a module in each unit. It's the thermostat. Within that unit, you have on a Home Depot, you have a remote sensor in the store. That sensor is hooked into the module at a Home Depot and at a Target and at a Ulta and a Kirkland's. zone sensor tells the module in each unit what the temperature in the zone is. It doesn't talk to this, doesn't send the temperature here and then this decides what the temperature is to run here. This all happens locally. All this is local monitoring, guys. This is not local control. This is a remote control. It's all local control. Remote monitoring and program changes is all an EMS system does. They don't run it from Georgia or run it from Minneapolis. They just program it and monitor it from there, so that everyone understands what's going on here. So, with that said, you have a COM cable, goes from each. Most of these stores use what's called a daisy chain. A cable from the router in the store goes up to the first unit, from the first unit to the second, from the second to the third to the fourth. There is a limit on how many feet they can go and how many units they can run. At a Target and a Home Depot, you usually see this broken into 2 or 3 daisy chains. So if you have a problem in a group of units, they're probably on the same COM cable. You could have a cable cut here. You'd be able to communicate with this unit, but you would not be able to communicate with 2, 3, and 4. The problem, as we know as technicians, is this is not easy to find. This cable is below the roof line. This is the roof line. This is the drop ceiling in an Ulta store. These cables run up here like spaghetti. None of them are labeled. There's no markings on them. It doesn't say, come find me, I'm right here. This stuff is difficult, but if you have unit number 1 and 2, but you don't have COM to 3 and 4, you've got a wire broken or something disconnected between, 2 and 3. You can just process of elimination, guys. You just got to break it down into the simplest terms. The problem is we don't know how they ran these cables. Target can tell you this. Target has blueprints in most of their stores, and they can tell you which units are in which chain, which chains have a diag in them, or a repeater, as many guys call them. But this is hard to figure out sometimes. So there's a little bit of time spent, but it's not impossible. It's just time consuming. So with all that said, everyone, that's the basics of the system. One of the most common mistakes, problems, trouble calls, especially at Ulta stores, because Ulta's got too many cooks in the kitchen with all their different EMS companies and everything else going on, is the assumption that because there's someone has written on unit number 1 with a black marker that's unit number 1. I might call it number 1, but EMS might call it number 3. Like here, I got 2 and 3. You have to know that you're talking the same language as the EMS company. In other words, I'm standing at this unit. I think this is number 1. And if you're not sure, turn the power off to this unit. You turn the power off, within a minute or 2, they will lose communication with that unit, because that board in that unit gets its power from the unit. It steals power from the unit to power this. When you kill the power to this board, it stops communicating. Now you know that I'm standing at number 1. Now you go in the store. This is another common mistake, the different zone sensors. If you assume that every one of these sensors was wired right, especially in a new store, you're in for a rude awakening, guys. I assume every time I walk into a store and there's a problem that there's something wired wrong, and until I can prove that it's wired correctly. So what I would do is I walk into the stock room, I find the zone sensor, I disconnect the 3 wires to the zone sensor while I'm on the phone talking to EMS, and they say, hey, we just lost the zone sensor for number 3. And you say, well, I just disconnected the zone sensor in the stock room. Problem solved. Now you know what has been going on in that store. So use EMS as a tool to help you, but EMS's job is not to fix the units. That's what they call us for, guys. Don't get mad at them because they can't tell you how to fix it. That's where we come in. They are there because they can help share the information that they see on their screen, is how you can use them. You just have to know how to use them as a tool and not get mad at them for it. So that's the basics of the layout of the system, guys. Again, I'm going to try to keep this kind of short on a Friday night. I am on call this weekend, but on a Novar store, I wanted to go over this quickly. Novar ETM, again, electronic thermostat. It's just a thermostat. It's got inputs and outputs. This is a thermostat or a terminal strip on a rooftop unit. Let's call this a carrier for conversation's sake. If I want the fan to run, the ETM module has relays in it. In the module, they're just relays in the circuit board. You can see them on this module, these little relays stacked up here. On terminal 26, there's power going in that's hot, 24 volts to every one of these normally open relays. When the module, aka thermostat, says I want to run the fan, just like on a Vision Pro, it closes this relay. That little green light will come on or red light will come on, telling you that the coil has been energized. It doesn't tell you that the output is hot. Sends 24 volts down to the G terminal on the unit and tells the fan to run. Sends 24 to the Y1, tells the first stage compressor to run, second stage heat, just like a thermostat. So get out your meter, check. Don't assume because the light is on the module that you've got power on your G. Again, I can't stress it enough, guys. One of my sayings that I preach to my technicians all the time is prove your theory. Put a meter on here. Do you have 24 volts here? Hot and common. And this is polarity sensitive. I see these mixed up all the time, guys. It'll cause you communication problems. Power supply to an ETM module or a RTM module or a Distech controller is polarity sensitive. Hot's got to be on hot, common's got to be on common. But use your meter. Check voltage out, voltage in. It's just a thermostat. There's no real rocket science going on there. Again, just basics here tonight, everyone. The next thing I want to show you is checking basic communication. Novar module, ALC target, Distech would be a blue controller. Andover controllers for some of the older Altastores, BACnet and Prodigy. But some of the Linux units have BACnet on board. The only difference then is they don't need this board on a Linux with the Prodigy. The BACnet ties right into the Prodigy board, so it talks BACnet. BACnet, everyone, for those of you that don't know, it's not that big of the mystery. BACnet stands for Building Automations Control Network. It was designed to control HVAC lighting. That is what the software was built for. BACnet is like Windows software is to a computer. BACnet is just a common open protocol, open codes. Unlike Apple that has all their codes locked up, BACnet is a common code that a bunch of engineers agreed on that could be used for building automation. So a bunch of different kinds of devices can all talk the same language. That's all BACnet is. It's just a chunk of software. It's an operating system is probably the better way to describe it. Anyway, network communication on a Home Depot or a Target store with an RTM module that I had a picture of here. I think it fell on the floor. Oh, here it is, guys. Either one of these. Network cable comes in from the router to the unit. If it's a unit that's in the middle of a daisy chain, you'll have a set of cables coming in from point A, and then these cables go out to the next unit, to the next unit, to the next unit. So if you have two sets of cables, two pluses, two shields, two minuses, you're in the middle of a daisy chain somewhere. If you only have one set of cables, you're at the beginning or the end of the chain. To check it, you disconnect these 3 wires. If you have 6 wires, you disconnect all 6. You make sure you pay attention to the colors, tape them, put zip ties on them, take a picture of them before you take them apart. Polarity sensitive, the minuses got to go on minus, the shield's got to go on shield, the pluses got to be on pluses. You can't mix that stuff up. Disconnect the wires, take your meter and check for DC voltage from plus to shield. You should have 2.5 volts DC. From minus to shield, you should have 2.5 volts DC. On the board, with the wires disconnected, on the communication board, from plus to shield, 2.5 volts DC. Same thing. And from minus to shield, 2.5 volts DC. Here's the key, guys. You could have plus to shield and have 3 volts, and minus to shield and have 2 volts. So long as it equals 5 volts DC. Very important, especially on Novar. It's got to equal 5. talk to the EMS guys. They can tell you if they're happy with it, not happy with it, want you to dig deeper into it. So pay attention to that. I'm just checking to see if I'm in focus here. Sorry, guys. So that's network communications in the simplest of terms. 5 volts DC, 2.5 volts DC from plus to shield and minus to shield with the wires disconnected. Check the wires. If you have 2 sets of wires, check each set of wires individually, so you know if this cable is good but you got a problem on that cable coming back or going to it, so you know where the short is between this unit and the next, or this unit and the one before it. The zone sensor on Novar, just 2 wires, 10K sensor. 77 degrees is 10K, 10,000 ohms. I'll send a little chart along in the email, you guys, so you can test it. You just disconnect the wires, check from plus to minus on the sensor with the wires disconnected, check your resistance. See if it's the same as, see if it matches the chart for a 10K sensor on space temperature, and you'll know if you've got a good sensor or a bad sensor. Something I wanted to mention on Novar, especially, that I found out the hard way a couple summers ago, is if you have a short in one of these, let's say this cable, as it runs up through the store, got hit by a forklift, and you pinch these and short them to ground on a post or something. A Novar board, pretty great design, has onboard circuit breakers for ground fault. If you have a short to ground here, it shuts the board off. You'll have a board that looks like you got a bad circuit board, and it might only be a shorted wire on a sensor. I found it several times, guys. So if you have a board that's bad on any unit, the first thing I would say is, I always say to swap the board with another unit and see if the problem follows the board. Does the problem stay with the board and go to the next unit, or does the problem stay with the unit you're at? And then you can figure out, is it the board or is it a problem with the unit? On Novar, I always disconnect the zone sensors, the discharge temp, return temp, and zone sensor wires. And when you do that, if all the lights start coming back on, you know you've got a sensor that's shorted to ground. Again, it's got automatic ground fault built into it. So if you're putting in, board after board after board and you can't figure out the problem, start looking at, know that it's got onboard ground fault, and it will shut the board off if it senses a ground fault. That's about all I got, guys, for tonight. I'll go into some more detail later, or if you guys have some feedback and you'd like me to touch on some things. I wanted to show you a couple of things here. Number one, on Novar, most of you guys know this, on this board with the relays, these little pins, if you jumper these 2 pins, it energizes this relay. So you can tell it to run cool 1, you can tell it to run cool 2, heat 1, heat 2, or fan from the Novar board. That way you're testing the output from the Novar board to the unit, not just assuming that the wires are good. Do the same thing on a Target store. I don't know if you guys can see this or not. I'll see if I can get this close enough here. Over here on this side, there's little hoops on the newer ones. Well, these are soon to be obsolete too, but there's little hoops. If you put a little jumper and hook those 2 hoops together, it'll energize the output on a Target board. This is the output side of a Target board. This is the input. Safety alarms. These are all analog and binary inputs. These are all digital and analog outputs on this side of a Target board. The Target is a little bit different. Most of you guys know this, but this is what they call a diag or a repeater. These are in the IOP panel, but they also put these in a couple 3 units on the roof. They put them toward the middle or the end of a string. They monitor or diagnose the noise on the line, and they also add a little bit of voltage at a slightly different frequency, and it raises the communication protocol so that it gets above the noise. So it boosts the signal, in layman's terms, puts the signal on a little bit higher level so it will get above any noise. If you have a Target with one of these in a rooftop unit and you shut off the power or lose power to that unit, you'll lose, sometimes you can lose the whole store. It'll put a lot of noise on the line. If you get a noise on the line call at a Target, go to the roof and see if you have any units with a diag or a repeater board in it, and make sure the power is onto that unit. If you lose power to this diag on that string, you'll lose the whole string, you'll lose the whole store, or they might not be able to communicate with the store. Another thing to look for, guys, is if this set of LEDs on this diag board, this is in an IOP panel at a Target. You can see it right here, it's just zoomed in. If these are flashing up, 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 and just non-stop, that means it's resetting. And if it's resetting, it's trying to get rid of noise. It's got a bunch of noise on the line. You've probably got a unit off on the roof or a cable cut or something going on, but these should not be jumping up and down like you're cranking AC/DC on your equalizer. They should be at a level and maybe bouncing just a little bit, but if they're going from top to bottom in a continual heartbeat, that means they're resetting and there's a lot of noise on the line. That's about all I got for a Friday night, guys. I hope this helps. I hope I didn't confuse anyone. I hope I gave you enough to give you a little bit of confidence, get your feet wet, and have a little better understanding of basic EMS systems. They don't all work exactly the same, but they all are pretty similar in that their headquarters talks to the store via the internet. It's a router in the store. So if they can talk to the store, but they can't see the units, then you know that the problem is not here in the internet or into the router. If they can't see the store, in other words, they say we cannot communicate with the store at all, then either the problem is in the internet or in the router, or sometimes if you have a cut or broken cable here, it'll cause enough interference where this will go into a reset, and there's so much noise and interference on the line they can't communicate with it. Be like if you cut your modem cable at home and shorted it to ground or something. So, with all that said, guys, thanks for listening. I know you guys are out there busting ass every day. It's been a long, hot summer. Want to wish everybody a very, very happy 4th of July weekend. Hope you get some time to spend with your families. If you're out there working, please be safe, stay hydrated, and stay safe, man. Have a good weekend. Bye.